Hi there, welcome back. Last week we talked about Gemma 2 and the release of Gemma 2 and how you can start using it today. And this is the blog post that we went through. And in this blog post, the team also mentioned how they are using a tool for in-depth evaluation of language models. This has been outsourced for open source for a while, so I looked into that and I have a video for this. So today we will be talking in depth about LLM Comparator. LLM Comparator essentially goes on to the problem of figuring out how good are the language models. And the way to do that is generally of course, you can rely on certain scores that are outside available, the benchmark scores, or you can do your own evaluation. When you're trying to do your own evaluation, generally the trouble is that there's so much data that you end up being the task ends up being very labor intensive, and you probably don't have all that time. So one of the ideas that has been going around for a while is using another LLM as a judge for the outputs that are being produced by the models that you're trying to compare. So in this example, what we have is two models, Gemma and Gemini, and you use a third model, could be any one of these, to judge the responses that are being generated by both of these models. And you can do these judging on different criterias. So let's take a look at what does LLM Comparator offer. So this is LLM Comparator. It's already preloaded with this sample data that they are providing on the pair team. The code is open source, and we will take a look at all the other details as well. But this is the page that you generally come in to see what's going on. Here we have the prompt that was used, the response from the model that was generated. So in this example, they have taken both of the models are from Gemma and Gemma 1.1 and Gemma 1.0 instruction tuned model. So they have two models they're using. Uh, and then you see the prompt, you see the response that's generated, response from model B, and you try to figure out how same or similar the response is in here. So right here, the score is 0.0, so it's the same model. And if this response, if the score goes below 0, then B is better. If the response goes above 0, then A is better. And it depends upon like what your threshold is. So I think it's 0.50 right here. So a score for win rate is 0.25. So this is actually a really good tool where you can come in and upload all of these. First of all the things that are happening in the backend are happening with LLM as a judge. So you really have to do a lot of work. After that, looking at the metrics is also much easier because you come in and take a look at them in a more visual format. So if you are asking for specific things like describe the issues with Asimov's three laws of robotics, it can add the responses in here, but it can also provide a rationale list on how those rationales are helping it answer the question. Of course, on top of that, you can do other things like toxicity detection, sexual content detection, violent content detection as well. Uh, so just to go through some options in here, it highlights the matches. You can do monospace font just so it's more readable in case there's code contained in here. You have your own score for win rate that you can set up. Uh, and then the thing that I wanted to show you is this thing. Oh, let's just go by one by one. As you can see, score distribution overall, like what is better, A is better or B is better. You can see that there's a lot of things where both are fairly similar, but it seems like A is much better than B in some of the categories. And what we find is it's actually 1.1. So hopefully A is better than B, which was a lower or smaller model version or older model version in this case. Um, it also have metrics by prompt categories. So you might, if you are a company which is providing prompt as a platform for your audience to come in and ask questions, you might be seeing that, hey, we are more focused on giving science and technology answers, but we are not really worried about travel answers. So this allows you to make sure that the new model version that you are starting to use, or any changes that you have done to your prompts or models itself, and any other things that you have done, are actually moving the needle on the categories that you care about and not all of the other things. Okay, we also have rationale summary in here. It provides it essentially there's a full rationale in here. So this is the full rationale, but it uses this rationale to generate a rationale summary and then rationale list, and from that rationale list we have a rationale summary. In this summary, you can see like why does the model think that A is better. So A is better because it provides more details, uh, or it directly answers the questions, or is more accurate. You might be more interested in figuring out these details or optimizing on one of these. The thing that I really liked about this is custom functions. So you can have your own custom functions. Oftentimes, when we have a model generate responses, LLM model, you end up seeing that, hey, it's the word count is really high, and I want to optimize for a model which does not have a high word count. So I'm trying to reduce the number of words that it's using. And you can see the distribution is actually fairly similar in this case for both of these examples. However, it seems like the model B in model A in this case, 182, has a tendency to do longer responses, but not too long. It definitely moved the needle from like 166 over here on the longer side to 182 on this side. So it's definitely doing better than what model B was doing, which is 1.0 Gemma. Then also, depending upon your preferences, you might have a preference for contains bulleted list, contains headings, contains URL. There's another one which is contains sure. So this happens often where you ask a model to do something and it replies in starting with like sure I can do this, or sure here's how I can help you. And this has been like a lot of people don't like it, and it seems like that the team worked on it between 1.0 and 1.1, and there are, at least in this sample that we are evaluating, there's not a lot of words, or actually zero words, which start with sure. I found this example out there. So I ended up creating this. This is a custom function that you can add. So you can click here to create a new function, and you can add custom functions in here. This is the one that I created, so I'm going to show it to you. So this is a blog post I found where it talks about how since LLMs have been since people have started using LLMs, we have seen the usage of these few words accelerate a lot. A lot of research papers, a lot of blog posts end up having these words, which is not like 100% accuracy towards saying that these are the posts that were written by a model, but there's like it's some directional feedback. So when we run this, we see that there's both of the models actually have fairly similar usage of these words, dwell, crucial, and potential. I took a cursory look at the code, at the responses in here. It's mostly the potential, not really the delve part. Delve is more on the rationales, not on the actual responses that it has generated. So I think I found a few in here which were, but mostly it's potential. So you can see how if you are actually training a model to say, some people find that, hey, the model is very apologetic, and I want to make sure that my model doesn't say sorry. So you could build a new function in here, a Boolean function which says, doesn't say sorry, and like you're looking for a regular expression pattern for sorry in there. Or you can use similar thing to say it does not generate email, and you can look for that, or any other pattern that you're looking for. So this allows it to be very customizable. I had a trouble keeping this here afterwards, but the project is open source, so you can of course clone the project and add your functions directly into the code rather than adding them from here over time. So if you end up having multiple of these custom functions, you can just put them, create a clone of the code, and then put all of those directly in there. But when I just another thing that I wanted to talk about in here. I looked deeper into this, and they have another example in here that starting today, you can start using companion Python library to run evaluations. So I was really excited about this because until then, I had to generate this JSON that was used in this to generate this whole response in here, or this whole table. Now you can do all of this directly, programmatically from the code. So they created a Colab notebook, and I'm just going to walk through that. Uh, New package and good name, LLM Comparator directly. Then it connects to VertexAI. VertexAI is Google Cloud's platform where it allows us to use that for access to the models. Then we auth into Colab. We have a few functions that are provided by LLM Comparator. We have comparison, model helper, the judge runner, bullet generator, cluster generator, details like that. So this is actually clustering that's happening for these categories in here. and then the bullet generator is, I think it's this rationale list. Moving on. Here's a setup and authentication. I have hidden that just because you don't need to see it. And then you have your own inputs in here. So you can add multiple inputs. These are the three inputs on which we'll be trying to generate or trying to understand how good our model is doing. This you will have to generate, or you will have to find out. So you still have some work to do to generate these responses from model A, model B, and the prompt. So those are the three responses in here: prompt, response from model A, response from model B. Then you initialize comparator, you embed all these details, you run the LLM as a judge, and you see the comparison. You run the comparison results in here. And after that, once you have the file, you could download the file and load it onto LLM Comparator, or you can just have a embedded LLM Comparator right here. So, okay, we have these three prompts, the three responses that came out of that. We found, so this rating, these 6 raters in here, these are the ones that are being done by LLM as a judge. So it looks at these responses and confirms. So a really good one is this one. Okay, those are subjective, but this is very objective. Which is what is the capital of Korea? And we know that Seoul is the correct answer. And all 6 LLM runs that we did generated that as the correct answer. So rating flipped. Yeah, okay. So the question, even asking the question technique is different in here. So you're asking the flipped question versus not flipped question. So in both the cases, our LLM actually gave the correct answer, which is always A is better. These are again judges giving the answer, which is the correct answer. Either way, we come to the enough conclusion here is that like enough times LLM as a judge has said that this is correct answer, and that ends up saying that our responses from model A are probably more correct. And you can very quickly visually go through this response, go through this whole evaluation, and get the final responses out here. You can run this on larger data sets, give it a try, tell me how it goes. And if you have more thoughts, or if you want to do a deeper reading around this, the people in the AI research team at Google essentially wrote this blog post the day that it got released. I think it was during I/O time when it was released, or just a week before that. I think this is I/O time, yeah. And yeah, this is actually a really good blog post. Talks more about exactly how they are thinking about it, how they are working on this, and they're looking for feedback. So anytime you have more details, please feel free to send it back to them, or pass it along to me, and I'll try to get it back to them. Anyway, thank you so much for being here today to learn more about LLM Comparator. Next time, we will pick another tool in the machine learning trade and dive deeper into that. Thank you so much. See you around.